dear students, welcome back. So let's continue the session, preparation of alcohol. Acid catalyzed hydration and hydroboration already we have discussed. So let's move to the next preparation method, that is preparation of alcohol from carbonyl compound. Okay, it can be prepared from carbonyl compound. So carbonyl compound, we are familiar. We know what are carbonyl compounds. Aldehydes, ketones, carboxylic acid, ester, acid chloride. All those compounds are known as what? Carbonyl compounds. Okay. So first, among this carbonyl compounds, first let's see the preparation of alcohol from aldehydes and ketones. Okay. So among this carbonyl compound, first from aldehydes and ketones. Okay, and children, maybe this thing maybe you have studied in the section of aldehydes and ketones. Anyhow, just recall it once again. A primary aldehyde, okay, sorry, an aldehyde will always give primary alcohol and ketone will always gives secondary alcohol. Okay, so children, please remember these points before going to the chemical reactions. Always aldehyde gives primary alcohol and ketones will give secondary alcohol. Okay, so let's do the reactions. So this is a familiar aldehyde and only one carbon. So this is what? This is methanol. This is methanol and its common name is what? Formaldehyde. Its common name is formaldehyde. Okay, so this formaldehyde, from this formaldehyde we can prepare alcohol, and from aldehydes how we will prepare alcohol? That is by reduction. Okay, from aldehydes and ketones, which is on reduction, we will prepare alcohol. So reduction means what? Addition of hydrogen. So this reduction can be done mainly in two ways. One is direct hydrogenation, that is the normal hydrogenation, addition of hydrogen in presence of nickel, palladium, platinum catalyst. And in the second way of reduction is using reducing agent. Okay, so children understand, alcohol can be prepared from aldehydes and ketones generally by reduction. Reduction can be done in two ways. First one by hydrogenation. Okay, first one by hydrogenation. Okay, so here let's do the hydrogenation reaction for this formaldehyde. So hydrogenation, addition of hydrogen in presence of nickel, palladium and platinum. Then we know aldehydes will give corresponding primary alcohol. Okay, so here we will get CH3OH as the alcohol. Okay, CH3OH methanol, it is considered as a primary alcohol. Methanol is considered as a primary alcohol. So remember, formaldehyde on hydrogenation we will get what? Methanol. Methanol we will get as the product. Then again let's do the hydrogenation reaction of next aldehyde, that is CH3C double bond OH. Okay, this is aldehyde with a single carbon. This is aldehyde with two carbon atoms. So this is what? This is ethanol. We will name this compound. IUPAC name is ethanol. But we know the common name of this compound. This is known as what? Acetaldehyde. This is called acetaldehyde. Okay, so let's do the hydrogenation of acetaldehyde, adding hydrogen to this in presence of nickel, palladium, platinum. In presence of nickel, palladium, platinum. Then here also we will get alcohol CH3, CH2OH. The corresponding alcohol will be obtained. And this is a primary alcohol and this is also a primary alcohol. So children, just understand, whatever may be the selected aldehydes, aldehydes on hydrogenation, that is reduction, which will always give what? A primary alcohol. Okay. Whatever may be the aldehyde, branched aldehyde or any of the higher aldehydes, that will give corresponding primary alcohol. That is the first point. Now, let's move to the ketone. Okay, how we will get product when we will do the hydrogenation reaction of ketone. So, let's take a ketone. This is the third reaction. First one and second one. Moving to the third reaction. Let's take ketone CH3, C double bond O, CH3. Okay, so this is what? This is propanone. This is propanone, or the common name we can say that is acetone. Okay, common name is what? Acetone. So this propanone on hydrogenation. This is on hydrogenation. We know the hydrogenation is take place in presence of nickel, palladium or platinum. Okay, nickel, palladium or platinum. Then we will get the product as CH3, CHOH, CH3. Okay, CH3, CHOH, CH3. That is, the name of this compound is propan-2-ol. The name of the compound is propan-2-ol. So since OH attached to a CH, this is a secondary carbon. So this is a secondary alcohol. This is a secondary alcohol. So children, just understand the concept. Aldehydes will give, always aldehydes will give primary alcohol and ketone will give secondary alcohol. We have proved that with two examples, the methanol, basic aldehyde, which give primary alcohol, and acetaldehyde also gives a primary alcohol, and but propanone, acetone is a ketone which on hydrogenation gives what? Propan-2-ol. That means a secondary alcohol. Okay. Now let's move to the mechanism of this formation. We have already, I just wrote the reactions, I didn't give any explanation. So now let's move to the details of this reaction, how the alcohol formation occurs, what happens in between. Okay, so let's move to the mechanism. So here the same reaction I have written, reaction of formaldehyde with hydrogen. Okay, so how the reaction happens means, here this double bond, this bond between carbon and oxygen is breakdown. Bond between carbon and oxygen is breakdown, and we can write it as like this. Okay, yes. And here this adding hydrogen molecule, it splits up into what? Homolytic cleavage. It undergo homolytic cleavage, and we will get two hydrogen radicals. Okay, it will undergo homolytic cleavage, and one of the hydrogen atom is coming to this carbon, and other hydrogen atom is attached to this oxygen. One of the hydrogen atom, by the homolytic cleavage of this hydrogen molecule, we will get two hydrogen atoms. Okay, and from that one of the hydrogen goes to this carbon. Here we can say to this carbon, and the other hydrogen goes to the oxygen. So we can write the product as, so total count around this carbon 1, 2, 3, 3 hydrogen atoms, therefore CH3. Oxygen also gains the hydrogen, therefore the product is CH3OH. Okay, so this is what the mechanism. The carbon oxygen bond get ruptured. Okay, at the same time here also we can write down the hydrogen is splits up into, we will get two hydrogen. Okay, homolytic cleavage, we will get two hydrogen atom. One of the hydrogen atom goes to this carbon, and other hydrogen goes to this oxygen. This bond will get cleaved. Okay, so as a result, the carbon as well as oxygen, this bond is breakdown, so both will get each hydrogen. Therefore, just count the hydrogen atom around this carbon, CH. Earlier it was a single hydrogen. After getting this, it becomes CH2. That is why we will write CH3, CH2, and oxygen also gains hydrogen. Therefore, CH3, CH2, OH we will get as product. Okay. At the same time, let's do the reaction of ketone also. So ketone, we have selected acetone, CH3C double bond OCH3 on adding hydrogens. Here also the same thing happened. The bond gets ruptured and one hydrogen moves to the carbon and other hydrogen is given to this oxygen. Then we will get CH3. Then since this carbon gains one hydrogen, it becomes CH and other CH3 can be written like this. And since here this oxygen gains hydrogen, we can write as CHOH. Okay. So remember, in aldehydes or ketones, which is on reduction, the double bond C double bond O is breakdown and the hydrogen atom is attached to the carbon as well as to the oxygen. Okay. And from aldehydes and ketones, we can prepare primary alcohol as well as secondary alcohol. Okay. But we cannot prepare tertiary alcohol. We cannot prepare tertiary alcohol using this aldehydes and ketones. That is the main drawback of this method. Tertiary alcohol cannot be prepared from reduction of aldehydes and ketones. That is the drawback of this method. So now let's move to the second method, that is from aldehydes and ketones. Hydrogenation reactions already we have discussed, and the second one from reducing agent. From reducing agents or using reducing agents, because first reduction was done by hydrogenation reaction and second using reducing agent. Using reducing agent. So the same aldehydes and ketones have been selected. Acetaldehyde and acetone is selected. So the main reducing agents we used. Is, maybe you know this. One is sodium borohydride, NaBH4, and other one is lithium aluminium hydride. So note down this. Sodium borohydride as well as lithium aluminium hydride is used for reducing agents. Both are strong reducing agents. Okay. So here this acetaldehyde on treating with lithium aluminium hydride, we will get the same product as a previous. Okay, we will get here primary alcohol CH3 CH2 OH, and here the other one we can take NaBH4 we can take. So this sodium borohydride is treating with this ketone. It will give secondary alcohol CH3 CHOH CH3. Okay. So the same product we will get instead of NaBH4. Here if we will use lithium aluminium hydride, the product is same. So children, just understand, if we reduce aldehydes and ketones either by hydrogenation or by using any reducing agent, the product formed is aldehydes primary alcohol and ketones will give secondary alcohol. That is the process take place here. And again here also the mechanism we can say the carbon oxygen bond get ruptured and here hydrogen, because this is what these two are strong reducing agents. That means it has to give an hydrogen atom. So let's see the mechanism of this lithium aluminum hydride, how it gets breakdown. This is not there in the syllabus, but you just understand how that formation occurs. Okay. So lithium aluminium hydride LiAlH4 is breakdown into Li plus and AlH4 minus aluminium hydride we will get. And from this aluminium hydride, again it splits up into H minus and AlH3. So this H minus is actually used for what? H minus is used for reduction. Thus the reduction occurs. And again one more thing, comparing this sodium borohydride and lithium aluminium hydride is more stronger than sodium borohydride. Generally we will say both are strong, but when we will comparing that two, lithium aluminum hydride will be little more stronger than sodium borohydride, but anyhow there is no difference in the product formation. Products are same. If you will use either lithium aluminum hydride or sodium borohydride, the products are aldehydes corresponding primary alcohol and ketones will give corresponding secondary alcohol. Okay, and one more thing related to this lithium aluminum hydride, this is a highly costly chemical. This is a costly chemical, lithium aluminum hydride. Okay, so this is the way prepare alcohol using reducing agent. Next method of preparation of alcohol, section of carbonyl compound is from carboxylic acid. Aldehydes and ketones is over. Next carbonyl compound is carboxylic acid. So let's see how can we prepare alcohol from this carboxylic acid. So let's take the general carboxylic acid. Carboxylic acid is represented as RCOOH. So okay, in this manner I have represented the carboxylic acid. So carboxylic acid on treating with reducing agent lithium aluminum hydride, the strong reducing agent lithium aluminum hydride in presence of water. Okay, lithium aluminum hydride aqueous solution, we can prepare alcohol. Okay, let's see what happens here. So we have already studied the mechanism of breakdown, how the LiAlH4 is breakdown. So lithium aluminum hydride can produce maximum 4 hydrogen atoms, right? It can produce maximum 4 hydrogen atoms. So here what happened is that this bond between carbon and oxygen is breakdown. Bond between carbon and oxygen is breakdown, and one of the hydrogen atom goes with OH and eliminated as H2O. That can be written first. One of the hydrogen atom from this LiAlH4, total it has 4H, and from that one combined with this OH and eliminated as what? H2O. Okay, and here the remaining one, here this carbon oxygen bond also get ruptured, and now here total 3 hydrogen is remaining, and from that 2 hydrogen atom goes to the carbon and 1 hydrogen goes to this oxygen. Clear? Just note down these things happens here. We will select RCOOH, carboxylic acid. First of all, it is treating with lithium aluminum hydride followed by hydrolysis. That is what happens here. So first of all, this bond between carbon oxygen, here it's breakdown, and this OH takes 1 hydrogen and eliminated as what? H2O. That is happened first. Okay, and now let's move to the next part here. Here again carbon oxygen double bond gets ruptured and 2 hydrogen atom given to the carbon and 1 of the hydrogen is given to the oxygen. Therefore we can write down the product as RCH2OH. The product is what? R. This carbon gains 2 hydrogen, therefore RCH2OH. That means we can say the carboxylic acids will give primary alcohol. Carboxylic acid on reduction gives what? Primary alcohol. And for the reduction of this carboxylic acid, we have used lithium aluminum hydride. It's a strong reducing agent, but I told you this is highly okay, this is a costly substance. So only for the preparation of some special chemical substance only we will prefer lithium aluminum hydride because of this high cost. So normally from the carboxylic acid this method is not preferred. For the preparation of alcohol from carboxylic acid, this method is not that much preferred because this is highly due to the cost of this LiAlH4, this method is not that much preferred. So anyhow we can prepare alcohol from carboxylic acid through an alternative method. That is, first of all, this carboxylic acid RCOOH, carboxylic acid is converted to ester. Carboxylic acid is converted to what? Converted to ester. So this is what? Ester. So how the conversion occurs means This is we have done in the practical session during the salt analysis, esterification reaction. For acetate ion we have done the esterification reaction. So normally how esterification happens, a reaction between carboxylic acid and alcohol in presence of a mineral acid catalyst, right? So first of all what we are doing here means convert this carboxylic acid in presence of an alcohol, convert this carboxylic acid into ester. Okay, this direct reaction we can't use due to the unavailability of this lithium aluminum hydride. So that's why we'll move to the alternative method. And here first of all carboxylic acid converted to what? Ester. So this is the basic form of ester, RCOOR dash. So this is called ester. So how the ester is obtained means carboxylic acid and alcohol in presence of a mineral acid catalyst, we will get what? Ester. Okay, and again further this ester on hydrogenation, ester on hydrogenation in presence of catalyst, catalytic hydrogenation, in presence of catalytic catalytic hydrogenation. From the ester we can prepare alcohol, not a single alcohol, two set of alcohols can be prepared. So let's see here what happens. From ester on hydrogenation in presence of this catalyst, here this bond will break down and one of the hydrogen is subtracted by this oxygen, and first we will get R dash OH. R dash OH will be obtained first because this is ester on hydrogenation followed by hydrolysis. Here also hydrolysis is occurs, hydrogenation followed by hydrolysis. Here actually what happened means, first of all bond between carbon and oxygen, this single bond between carbon and oxygen is break down, and hydrogenation reaction means plenty of hydrogen is supplied, and from that one of the hydrogen is takes by this oxygen and it is eliminated as what? R dash OH. Okay, so now this is the remaining part, R C double bond O, and here also the bond between, double bond between carbon and oxygen is break down, carbon accept 2 hydrogen and oxygen accept 1 hydrogen, and it turns to what? RCH2OH. RCH2OH is a primary alcohol. This is also what? A primary alcohol. So children, this is what happens in the reduction of ester. Okay, so this method, this second method, we can consider as a preparation method of alcohol from ester. By skipping this conversion, it can be from the ester on catalytic hydrogenation, we can prepare what? Alcohol. Whatever may be carboxylic acid or ester, on reduction we will get corresponding primary alcohol. So children, I think it's clear that just understand the mechanism of formation. Carboxylic acid generally normally used method is lithium aluminum hydride. So lithium aluminum hydride supplies 4 hydrogen. So here one of the hydrogen is takes by this OH and eliminated as H2O, and here 2 hydrogen is accepted by this carbon and 1 is given to the oxygen, and that part we will get RCH2OH. So since it is attached to a secondary carbon, a primary carbon, this is a primary alcohol. And in the second case, why this method is not preferred? Due to the unavailability of lithium aluminum hydride. So we will move to the alternative method. First carboxylic acid converted to ester. This reaction is known as esterification reaction. Okay, this part, this is called esterification reaction, and this ester on catalytic hydrogenation followed by hydrolysis, 2 set of alcohols can be prepared, 2 set of primary alcohols can be prepared. Okay, make sure that you are thorough with the mechanism. Simply don't by heart the equations, just understand the way of formation. Whenever you are writing to the notebook, first of all please write the straight reaction, and in the bracket you can mention the mechanism or how it happened. 2 hydrogen coming to this carbon and 1 hydrogen coming to this to this oxygen, Like that, the inner things happens, the interior mechanism you can just mention inside the bracket. Okay, so that's all about today. The preparation of alcohol from the carbonyl compound. Actually, it's not completed. Will be continued in the next session. Okay, so thank you all.